So we're here at IBC, and so who are you?
Hi, I'm Neil Force. I head up the engineering efforts in Altera for all of the video technologies that we provide in the IP domain.
So what does Altera do?
We provide FPGAs, programmable logic devices.
So you're one of the leaders for FPGA stuff?
Absolutely. We are the leaders in FPGA.
You are the leader in FPGA?
Absolutely, because of our leading presence in 14 nanometer technology with FinFET on our Generation 10 devices.
So this is Generation 10 you're talking about here. What is Generation 10?
Up until today, well, recently we've had a succession of releases to our device families and our portfolio. Moving through our numbering system, 1, 2, 3, 4 and 5. ARIA 5, Stratix 5 is our current release market name. But we've leapfrogged the competition with our Generation 10 technology.
Leapfrogged?
On the basis that we've gone for 14 nanometer FinFET technology through the Intel fabs, which enables us to have a much faster time to market for FinFET technology at true 14 nanometer with lower power and a much higher computational capability.
Yeah. So you have, can we just look at this? What is going on here?
That's going on here. This is 3 gig, sorry, this is 12 gig SDI. 12 gig SDI demo.
What is a 12 gig SDI and what is that for?
So,
you're working with ARRI, with some, like, there's a camera up here?
Okay.
What's going on?
Talk about the camera up here.
Yeah.
So this is a professional broadcast camera. It's a 4K P60 capable camera, and that also has a Stratix 5 device. That's an Altera part. So that's being showcased here on the basis that it's the best-in-class camera of its capability.
And your chip inside.
And our chip is inside.
So the only way that this can work is with your FPGA inside.
Absolutely, and that is SDI connected to our real-time demo of our HEVC ultra-low latency encoder running on Stratix 5.
So, what is this? Sorry.
It's our Stratix 5 development kit showing the availability of our dev kits that allow customers to prototype their own IP on our silicon in readiness for a production scenario. So any one customer can buy this from our website and develop on it their own IP.
This is Gen 10, Generation 10.
No, this is Generation 5.
Generation 5, sorry. But the Generation 10, where do you have that demo right here?
Well, that's our next generation silicon, the samples of which came out of our fab last quarter. Select customers on the early access program have access to that silicon today, and we are releasing Generation 10 silicon with a multitude of embedded ARM processors in the very early in 2015.
And so Generation 10 is ARM?
Generation 10 is ARM enabled, as well as a smaller portfolio within the Generation 5 family. It also has embedded.
So what does it
ARM.
mean? There's some ARM somewhere and then FPGA and it's somehow connected? How does it work?
Exactly like that. There's a very high low latency interconnect bus between the multi-core ARM hardened logic within the silicon die, surrounded by FPGA fabric.
So this is ARM 64-bit?
It's ARM A9s.
A9s?
In our current implementation in Generation 5, but in Generation 10 it's ARM A35s.
And so you have, what's it called? So there's, what is done by the ARM, what is done by your FPGA? How does it work? How do you...
We're the facilitator of programmable logic, and it's up to our customers to utilize that logic to their application as they see fit. So we have no pre-prescribed target for ARMs. We provide a Linux operating system that allows our customers to embed whatever application they want. They can go bare metal if they want, to allow them to build a software-centric solution on a very highly configurable hardware platform.
Nice. Can we try to see what's going on here? So you were saying, sorry I interrupted before. What is this?
This is SDI. Are you familiar with SDI?
That's the cables that professional cameras have, right?
Exactly.
And so, what's going on here?
Well, Ben's about to explain.
Okay.
Ben.
So we have 12 gig SDI signal coming from a Tektronix AWG waveform generator. That's going through a TI driver part here. It goes through 40 meters of cable, and then back through to a Stratix 5 FPGA. So in here we have our IP core. So this has a 12 gig SDI megacore. So it's splitting out the 12 gig SDI signal to 4 3 gig SDI signals. These then go through drivers, and then they come out as 3 gig SDI at the back. If we look up at the monitor here, that's showing the output of one of the quadrants.
Nice. So that looks cool.
Yeah.
Okay.